So hello everyone, a very good morning, good afternoon, and good evening to all. Dear authors and invited guests, welcome to the technical session 3B. My name is Anisha Mishra and I am the moderator for the session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the International Congress on Information and Communication Technology, ICICT 2023. The eighth edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th and 21st February 2023. And the virtual event will be held through Zoom today and tomorrow, that is 22nd and 23rd February 2023. I hope you all will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 6 presentations and each presenter will be given total 12 minutes for the presentation and 3 minutes for the question and answers. So, and on 10 minutes, I will raise a gentle reminder. There is also another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So just before we start the session, I would like to introduce you all to the chair for the session, Dr. Nilanjan Dey. Dr. Nilanjan Dey is an associate professor in the Department of Computer Science and Engineering, Techno International New Town, Kolkata, India. He is a visiting fellow of the University of Reading, UK. He also holds a position of adjunct professor at Ton Duc Khang University, Ho Chi Minh City, Vietnam. He is the editor-in-chief of the International Journal of Ambient Computing and Intelligence, IGI Global. He is the series co-editor of Springer Tracks in Nature-Inspired Computing, data-intensive research series, and co-editor of Advances in Ubiquitous Sensing Applications for Healthcare. He is an associate editor of IET, Image Processing, and editorial board member of Complex and Intelligent Systems, Springer. So welcome to the session, sir. And we
Thank
also
you.
have.
Thanks for the introduction. Sorry,
Yeah.
my mouth myself is getting muted. Please continue the session. Yeah.
Okay. So we have another session chair also for the session, Dr. Francisco D. Pascalis, but I think he's facing some technical issues to join the meeting.
No, I'm here.
So,
I'm here.
Oh, okay.
I'm here.
Okay, so let me just introduce you all to the session chair. Yeah, so Dr. Francisco D. Pascalis is a senior lecturer in financial law at Brunel University, London. Prior to joining Brunel, he worked as a research fellow at the Chair for Banking and Finance Law at the University of Zurich, where he contributed to research and teaching activities in the field of corporate law, banking law, and international finance law. His research interests are banking law and regulation, EU financial law, international financial regulation, regulation of financial markets, financial technology, and digitalization of financial services. So welcome to the session, sir.
Thank you.
Okay. So now we'll move further and we'll start with the presentations. And I would like to invite our first presenter, Christian Guzman Ruiz, to present his paper on the title, Adapting Atmospheric Chemistry Components for Efficient GPU Accelerators. So dear presenter, you may please start your presentation.
Yes, let me a moment to share. Here. Okay, can everyone see my screen?
Yes, we can see it.
Yes, so I will start. I'm Christian Guzman. I will present, as she said, my work on called Adapting Atmospheric Chemistry Components for Efficient GPU Accelerators. This is a collaborative work between the the BSc, and also and also a person, Matthew Dyson, that is actually in the National Center for Atmospheric Research. So to present a bit of the BSc part of my group, I'm currently at the Air Science department. From this Air Science department, there are a small group that is the performance team that specializes in provide HPC service to find main bottlenecks of our operational air science model. So I'm continuing to bit a bit of context or motivation about what is my work focus. First definition, the atmospheric models can be briefly defined, as a mathematical representation of atmospheric water, gas, and aerosol cycles. From these atmospheric models, we have to remark the resolution of chemical processes from the computational point of view, because it can take up to 90% of the time execution. So since we are the performance team, we focus on this high time execution, and usually try to reduce execution time and do a performance analysis and about what is happening. So some background, this is to explain the tools that we are using in this work. First of all, the Monarch is the atmospheric model that we are working. From this atmospheric model, we can see that it's divided between two parts, the physics and the chemistry. And the chemistry part takes around 80% of the execution time. Also, the chemistry part is divided in multiple modules. And this atmospheric model, it's currently only executed with MPI. And it can simulate different domains of the atmosphere. So also for this Monarch part, we only want to focus on the chemistry part, as it takes more, and we will use from the chemistry solvers that Monarch has available. We'll use a CAMP, which is a new framework. So from this CAMP solver, we will focus only, since this is a preliminary work on studying the GPU advantage on these models. We divide also the chemistry part in two parts. One is the CBOT package, that is an external solver that is using CAMP, and the internal functions that require, that the CBOT package requires from CAMP, that are the called derivative and Jacobian. Most of the time is consumed by the CBOT package, 70%, but we will focus on this derivative Jacobian part, mostly for the derivative, only to see if our approach can be, can have some beneficial to translate more parts of the code, no? Because the derivative is a very simple function that we can work on. So to define a bit this derivative, we can define a chemical reaction as a combination of stochastic coefficients and the species concentrations. So basically, the derivative function can be summarized as the sum of multiplying the stochastic coefficients with the species concentration. So it's like this, like all the chemical reactions happening, but without counting the time step, the next time step. It's only in the same time step, no? So about this our implementation, summarizing the background, the domain decomposition of the atmosphere results in multiple grid cells per each MPI process that currently are computed in a loop. In the right, there are the image with the workflow. Like we can see that first the Monarch solve the methodology, then it will take this cell, solve the chemistry, sending only one cell, and then repeat the loops. And this happens for each MPI rank. And inside this chemistry, we have the OD solver with the CBOT and this derivative and Jacobian part. The cells can be solved in parallel also with the GPU. So a GPU kernel, but first to do these cells, a GPU kernel needs to receive all the cells at once in order to compute them simultaneously. So somehow we have to move these cells from the monad part to the derivative part, no? To move inside CAM and inside of our simple function. So our approach is to adapt the chemical module to solve these multiple cells in the base CPU single-thread implementation. So our approach is called multi-cells. Basically, at the left, we have the original version that we call one cell. And in the right, we have the multi-cell version. The difference is that in the multi-cell versions, we want to send all the cells information to the chemical solver. This also means that the data structure changes. So instead of having multiple different chemical mechanisms to solve, so multiple of the systems, equational systems, no? We have only a single system with all the cells. So we have a big differential system, no? A big system of equations to solve. So this has some consequences, some consequence. First of all, there are some species replication, and also the OD solver parameters are common for all the cells. So if the OD solver needs to specify some specific parameter for one cell, for example, the DT, it adjusts the time step size, then it can be, no, because it's receiving all the cells at the same time. This is also more sensitive to different convergence speed. So maybe the speed ups, well, the time to solve the equation change. No, that is something that we will see. And this is the summarizing the GPU part after these multi-cells. Basically, at the left we have the CPU workflow, and I want to highlight how many loops it has. It has 3 loops: the species loop, that is the concentrations; the reaction loop, that is the chemical reactions; and the cell loop. So we summarize these 2 of these loops to the GPU. Basically, the GPU only contains 1 loop, that is the species loop. And these loops are computed by a single thread each. No, so one thread computes a cell of the species of the reaction X. No, so with this we also make some optimization that basically is about the GPU data storage. So the default data storage for the CPU is not so optimal for the GPU because of how it's because the threads in the GPU are accessing the data memory in parallel instead of sequentially. So we change this structure to make it more efficient. So we can continue with the test. So we tested our implementation on the city power cluster from the Barcelona Supercomputing Center. That basically it can be summarized that it has 2 Power 9 CPUs with 20 cores each and 4 GPUs. And the 4 GPU for each node of the cluster. No. So for the software configurations, we have 2 versions. One of it is the GPU and the other is the CPU. The chemical configuration is very simple with only 2 reactions and 3 species, where species A generates species B and species B generates C. And the cells are the number of cells or equation of systems to solve. No, that this number is the common configuration for the monad case. We also tested the MPI for the CPU case, the 40 MPI case processes because it's in line with the GPU. So for the results part, here I show 2 images. One at the left is the speedup of the multi-cells with the CPU for the whole chemical solver. since the solver is receiving this data different from the base version, and as I said earlier, the solver can have some difference on solving. No, it can be faster, it can be slower. In this case, we can see that it's much more faster because all the cells are very similar between them, so it doesn't need to like compute a specific time step size for each cell. No, it can use the same OD parameters for all the time steps, and the speed up is very high. And also for the second part of the GPU version of the derivative, we can see that the final version with optimization is 1.6 better than the CPU version. So also we measure from the CPU version what parts are from data transfers between the CPU and the GPU, and what time is consumed for the computational part, no? And compare with the fully CPU MPI process, no? One GPU versus one CPU. So we can see that the GPU time is like 3 times slower than the CPU, but mostly because of these data transfers. So if we remove these data transfers, the computational time is better in the GPU than in a complete CPU. Now this is something to study in the future, no? To see how we can improve that. And finally, to make some conclusions as a summary, the multi-cells implementation can simplify the solving, which can achieve up to 8 speed up. The GPUs can improve the speed up by 1.6. Also, this 1.6 speed up comes by 30% for this specific memory access implementation. So taking care of the data memory for the GPU is also useful. And the data movement between the CPU and GPU represents 90% of the time execution. So that's all. Thank you for watching and hearing me.
Hi, have you faced any kind of synchronization problem?
So, sorry, I don't know if it's me, but I can't hear you very well.
You have faced any kind of synchronization problem?
Synchronization problem?
Mm-hmm.
What do you mean by synchronization?
Once you are dealing with multiple threads, this multi-core, so have you faced any kind of such kind of challenges like synchronizing those threads?
So, sorry, I hear you very bad. I don't understand your question.
What I'm saying is you are working on multiple threads, right?
Can you check your microphone or write in the chat, because it's very hard to.
I'm not audible.
No, at least for me, I'm not hearing you very well. It seems like a problem with the microphone.
Okay. Okay, Anisha, please continue. Anisha.
Yes, okay, sir. So the other session chair, do you have any question for him?
No, thank you.
Okay, thank you so much for the presentation.
Thank you. Anyway, I will be in the chat if anyone has any question. Thank you.
Okay, so now we'll move forward to our next presenter. And I would like to invite Benedetto Chimantem to present his paper on the title Analytical Cyclic Division of Dataset for an ANN type model, a case study in air quality prediction in subtropical area. So, dear presenter, you can please present your paper now.
Good morning and good afternoon, everybody, chairpersons, professors, experts, and ladies and gentlemen. My name is Benedetto, and I'm here to talk about analytical cyclic division of dataset for an NN time model. Later on, we will have a case study in air quality prediction in subtropical area. So we are trying to show how this approach makes differences in the accuracy of the model. So this is the agenda of this presentation. So we will have some introduction and the contribution, and so the methodology and so on, and conclusion. So first of all, ANN time model can be the assistant when predicting time series data. So analytical cyclic division of dataset is very important to help the model to better understand the cyclical nature of the climate characteristics. So for example, in Macau, there are obvious warm and cold seasons, which can make it difficult for a model to be trained if the whole yearly dataset is input to the model directly. With cyclic components here, that is warm and cold seasons, the model can more easily recognize those patterns and trends. So, for the contribution, so since seasonal LSTM model should be more stable than a non-seasonal one during the training process, especially in the multivariate model. So in our case, two cyclic division, cold and warm season division can help to identify pattern specific to the particular season. For example, air pollutant concentration may vary significantly between cold and warm seasons due to different weather conditions and human activity or those methodological systems. Experiment will carry out with those data in subtropical urban cities. So we chose Macau in our case. And the methodology, so we will have the literature review and the building of the system and explore the seasonal characteristic and to find the data source and compare the result and visualize those data into charts. So this is the monitoring network of air quality in Macau. So relatively, we have a good monitoring network for the air quality. So we choose Macau as our case study. So for the data source, the data used are obtained from internet. So we have the concentrations of the 6 air pollutant in from Macau institution and the weather and some elements parameters obtained from the Europe Center for Medium Range Weather Forecast Data Center. So totally we have 21 features for our model to predict those 4 gas elements and 2 PM, the particles, particulates. And this is the slide showed how to divide the season is better. So cold and warm seasons are very significant in Macau. So as you see in the table, those columns are air temperature, humidity, rain rate, number of rainy days, and the prevailing wind direction, number of days of thunderstorm, etc. So in our case, the cold season is from September to February, and the warm season is from March to August. So the red color highlights the warm season and the blue for the cold season. And if we extend the seasonal analysis in a spanning of 5 years instead of only focus on 1 year. So a 2-cycle oscillation is very obvious instead of the conventional 4 season, that is the spring, summer, autumn, and winter. So you can see the oscillation here. So we will model an LSTM multivariate model. So we will try 3 different kind of such model. One is for the whole yearly data, and the second one for the conventional 4 seasons, and the final one is the analytical cyclic division of the data set, that is the 2 cold and warm season. So we will use the 21 features as mentioned before to predict those concentration of the 6 air pollutants. So here is the matrix. So this is the MSE for the test result on predicting PM10. The blue color is the yearly model, and the red color shows that the result for the conventional 4-season model. So as you see, the error is bigger than that of the yearly model. So if we divide it into a 4-season way, it's not so good as we use it as a yearly model. And this is for the PM 2.5. This is for the data of year 2020 for the all 6 pollutant element. So the red color shows the worst results. And this one is different. It's compared with the our proposed model. That is the 2 cold and warm seasons model. So the green color indicates the better result. So this is the PM10, and on the left hand side, and the nitrogen dioxide on the right hand side. So the green color means that it obtained a better result. And this is for the PM 2.5 and carbon monoxide. This is for the sulfur dioxide and the ozone. So let's make a conclusion. So analytical cyclic division of dataset can help to improve the accuracy of a seasonal multivariate model. The comparison of those 3 kinds of model, that is the whole yearly data set, and the conventional 4-seasonal meteorological data set, and also our proposed 2-cycle cold and warm season. So as you see in the matrix, that is the best of among those. So we can conclude that the 2-cycle model is the best, and the conventional 4-season even worse than using the whole yearly data set. Perhaps the data set is divided into 2 small parts which cannot preserve the crucial seasonal characteristics. So in our future work, so we will do more analysis of the anomaly, for example, the typhoon season and the rainy season, rainstorm, such etc. And we will also focus on different degree of delay of influence for each pair of elements. So this is the visualization of those prediction testing. So the blue color is the actual data, and the orange color is the predicted data. So yes, and then you can see the predicted data is very match the actual data so much. So we can conclude that the model has an ideal result. So so we can we can think that kind of model can be used as an assistant to the operational subjective forecast of air quality prediction for the institution and using in the public services. So this is all my presentation. Thank you so much.
I don't have any query. Thank you very much.
Thank you so much for the wonderful presentation. And now moving further to our next presenter. And I would like to invite Ulvia Razieva to present her paper on the title Digital Twins in Agriculture as an Internet of Things Paradigm, the case of Azerbaijan. So, dear presenter, you may please present your paper now.
Good evening, dear organizers. Good evening, dear participants. It's already evening in Baku. Let me share my presentation. Can you see my presentation?
Yes, it is visible.
Thank you. I and my colleagues worked over this article, and this article discusses. I'm sorry, I cannot widen my screen. So, the article discusses the areas of functioning and features of implementing digital twins in agriculture as Internet of Things technologies. It's shown that the use of digital twins and the virtual representation of a real farm can significantly increase management efficiency, especially for suburban agricultural system. Our article presents an optimization problem, which allows the modeling of suburban agriculture that serves to provide the city with fresh products. Management of a virtual copy of the temporary material and human resources of the farm occurs through the capabilities of Internet of Things, along the control of several assets that work together or perform the same function. The study examines the features of digital twins in the formation of suburban crop and livestock production using system dynamic modeling. In conclusion of the paper, optimal values are obtained in determining the priorities for the selection of relevant data, which should be constantly collected and updated. The necessary steps have been identified to implement the Internet of Things in agriculture in developing countries. The system dynamic modeling solutions make a valuable contribution to the reproduction of entities and their interaction in agriculture. At the same time, the infrastructure and platform for automated data collection are the main ones for ensuring and adequately reflecting the state of resources in real time. As research on digital twins and IoT opportunities in agriculture in Azerbaijan is still at an early stage, modeling such farming system can be challenging. The system dynamic modeling methodology was applied in the work, which involves comparing data to provide an understanding of the underlying interactions and the behavior of the parameters under consideration. The case considered in the article is only a theoretical basis. I would like to pay your attention on the theoretical basis for designing a farming digital twin without trying to develop a scale reference model. The evaluation of the applicability of the presented scheme in the context of smart agriculture is being tested by MASCAD package of mathematical applications. Characteristic features of suburban farms in Azerbaijan, especially in Absheron, its region of Azerbaijan, is economic and social heterogeneity. Large commodity farms coexist here with small peasant farms. However, these small economies are far from homogeneous. Group membership is determined not only by assets, but also by gender, ethnicity, social status, since all of these involve an unequal ability to use the same reserves and resources in response to opportunities. The suburban area of Baku, taken as an object of study, is limited by, as I said, Absheron Peninsula. We have studied the changes as a result of application of system dynamic modeling. Let me show. Yes. In the delivery of fresh food products to the Baku agglomeration. For this indicator, some weighted average transformation distance is proposed. And in the problem of optimizing the structure of suburban agriculture production presented in the article, we have the objective function, which assumes the maximization of marketable product. Here is our optimization problem. And we can see the number of conditions that takes this one, that takes into account the characteristics of the proximity of an agricultural object to the city, of urban food waste to the city. We talk here about the labor resources, technical means, and so on, and regarding the use of urban food waste as animal feed. And here we have some indexes. They shows us the set of suburban agricultural production area, some disjoint subsets, some subsets of products, seeds, on-farm, non-productive consumption, production resources, and so on. I don't want to bother you but by counting these variables. And we have such results. The data on, we have some two prognosis models. The data on which digital twins are based is divided into pre-collected data and data collected specifically for the creation of digital twins. And here we have two tables on Baku agglomeration, Baku suburban farms, and as I said, the Absheron Peninsula, Absheron is the economic district. And although these divisions are arbitrary, in practice it will be possible to gain new reasoning and knowledge thanks to connection between them. Taking into account the proximity to the city, because we considered only the case of suburban farms, according to the model, this model, and we have the results in form of tables. According to the model for optimizing the structure of suburban production, options were considered to increase the production of vegetables in greenhouses by 15 and 30%, milk by 30 and 40%, eggs by 25%. And in this table, we see that we prognose the improving of results in vegetables on open ground by 20% and 35%, milk by 30 and 40, and egg production, for example, by 15%. And we see the result, the shown results give us the better. The conclusions gives us the better results in when we construct the digital twin of suburban farms. Thank you very much.
I have a question.
Yes,
Can I?
please.
Yeah, thank you for
Yeah,
your
no
presentation. Thank you for your presentation. And could you please elaborate further on the theoretical framework you mentioned in one of your slides for the design of the digital twins?
Yes, this methodology of our work was built on the gathering of information, data interviewing. We have interviewed more than 150 farmers, suburban farmers near Baku, and our conclusions were based on the program designed for building of this digital farm. But again, I want to say that it's just a conceptual framework, because our big limitation is not readiness of our infrastructure in Azerbaijan for constructing such kind of farms. It's like a paradigm of Internet of Things.
Thank you.
Thank you very much.
Thank you for the presentation. And
Thank you.
now we'll move further to our next presenter. And I would like to invite Loy Al-Nuami to present his paper on the title Neural Network Models for Time Series Analysis and Estimation. So dear presenter, you can please present your paper now.
Thank you, sir. Good evening for everyone. Just want me to share my screen. Okay. Good evening for everyone. Our presentation today about neural network models for time series analysis and estimation. I'm Loy Naimi from Oman College of Management and Technology, a faculty member in Computer Science and Management Information System Department. Today, inshallah, in our presentation will introduce the introduction, neural network regression model, the identifiability of multi-layer perceptron, the ability to generalize, practical search for the real modelize, the results and the discussion and the conclusions. As introduction, the time series analysis help organization understand the underlying causes of trends or systematic patterns over time. When organization analyzes data over consistent interval, they can also use time series forecasting to predict the likelihood of future events. Multi-layer perceptron, due to their universal approximation property, they were used as nonlinear regression model, and then for time series modeling and forecasting. Many articles discuss their techniques for purifying unnecessary parameters, especially in the context of regression models, and researchers have extended the proposed technique to the case of time series. Most of these papers provide heuristics, but do not place themselves in rigorous statistical framework. This work proposed a set of theoretical results established in the context of time series neural models, which extends known results in the context of linear statistical models. Vector autoregression model has been proposed for multivariate time series data. Neural networks, including feed-forward neural network, is the powerful tool for the nonlinear model. In autoregressive model, the input layer is the past values of the same series up to certain lag, and the output layer is the current value. For simplicity, research has been placed only in the autoregressive framework. One can therefore consider a family of models called neural autoregressive models. The definition of the parametric model that has been specific functional form, which can be presented heterogeneous properties of parameter estimators. The given model and a given number of observation affected the corresponding learning and the statistical methodology that allows selection of the best model. To estimate the parameter vector, a fundamental property for obtaining consistency result in the identifiability of the model. This means that for a function representable by a given multi-layer perceptron, there is only one parameter vector that presented that function. The condition necessary and sufficient for the model to be identifiable in the case of multi-layer linear perceptron to a hidden layer having hyperbolic tangent for activation function. First precaution, to take is not artificially used to many hidden units. Therefore, characterizing multi-layer perceptrons that do not have a necessary hidden unit in manifest way by notion of irreducible multi-layer perceptron. Only irreducible multi-layer perceptron are considered, that is not comprising hidden units that are manifestly useless or exactly duplicated. This restriction does not prevent multi-layer perceptron from being over-configured. The work also suggested trivial transformations that do not change the function of the function represented by the multi-layer perceptron. One of the main difficulties involved in the use of increasingly complex functions, for the statistical estimation of processes is the phenomenon of overfitting. If a too complex or a little data use as a model, that is, the noise ends up from the modeling process that generated the data on which the data estimate the model. The principle of minimization of the structural risk defines a compromise between the quality of approximation and the complexity of the functions of approximation. However, the main drawback of the bound that they are valid only for the identifiable distribution independent random variables. The dimension is known only for multi-layer perceptron having indicator functions on the hidden layer. In the case where their activation function are hyperbolic tangents, there are only upper bounds of this dimension. Therefore, to reduce the over-parameterization of our model, it will rather use Bentley term, which depends on the number of parameters and the amount of the data. The philosophy of such approach, principle of permissibility, is quite like the principle of Sherwood's information criterion. The Sherwood's but use the theoretical framework is different as well as the resulting results. To determine the true model by initializing the structure, the process starts by taking all relevant input as obtained from the basic linear model and one input as a hidden unit. Then gradually add the unit in the hidden layer one by one. That's me calculating the criterion, the CIC, at each step. If the value of this criterion decreases, when the SIO norm remains stable or begin to increase, we stop looking for the model and we take it as the observed dominated f, the function max, the maximum value for the function. Note that with this methodology, the SIC criterion is assumed to be convex function of the number of hidden units. This is what the classically done when the CIC type criteria are used in linear model. It seems difficult to justify this hypothesis in theory. However, this method has advantage of being easy to implement and of giving good result empirically, as shown by the example treated in the following section and studies on the real data. It should be noted that with this method, the maximum amount of data is kept for learning, which makes it possible to make the most of the information they provide. The effectiveness of the CIC standard on simulation was tested with real architecture, the real parameter vector S, and the variance of the association Gaussian noise are known. The chosen model was released with two input and two hidden units, one output, and 8 parameters. One of the hidden unit is not bound to one of the input. The goal is to find the real structure as well as the right parameter. As this model has a few parameters, one can compare the exhaustive search with the stepwise statistical model, the SSM model methodology. The following table shows the proportion of the three constructs. We have three constructs A, B, C, and the estimation of the CIC held by the in-depth research on 60 simulations. We have 60 simulations, and we have three basic models A, B, C, and as expected, the true structure appears in 73% of the cases. So our model get 73% of the architecture, while model B get 12%, model C get 10%. The same thing when we apply the parameter SSM for the same set of data. So the following table shows the three main architecture selected by our ABC, again, with the calculation of the SSM for the 60 simulation models. It can be noted that this strategy provides for the same structure and that the real structure is presented in 62% of the cases. The main finding of this article can be extended in several directions. First, the exogenous variable can be added as input to the network, and the so-called nonlinear auto-regressive model with exogenous input X and NARX is studied. Then the delay can be fed into the input error to define the nonlinear type of automatic regression moving average model ARAM. Finally, all results can be extended to the case of multi-part output. This work shows that it is necessary to reduce the determinant in the case of the covariance matrix of experiment error. All these results were generated and then tested in simulated example and the real data such as the sports series daily electricity consumption, different real simulated series, but also recently on ozone level pollution, data for several places. By careful, all this applies only to stationary time series, and the use of neural networks does not eliminate the need for the traditional processing. It is necessary to eliminate the direction and frequencies. There are many programs for obtaining linear recording and estimating neural network parameters from regression model for time series answers. The SSM model, based on the CIC criteria, is used to select the best architectural design. Thank you. Thank you very much. Please, any question? Any question, please?
Okay, I think no one has any questions. So I thank you for your wonderful presentation.
Thank you, thank you, thank you, sir.
And now we'll move further to our next presenter. And I would like to invite Lisbeth M. Naranjo Mora to present her paper on the title, Smiley Antenna, a design of a SWB antenna based on an UWB antenna modifications. So dear presenter, you can please present your paper now.
Good afternoon. My name is Lisbeth Micaela Naranjo Mora. Okay. Today I'm going to talk about a smiley antenna design of a super wideband antenna based on ultra wideband antenna modifications. First, I am going to talk about introduction, antenna design, next final design, and measures and results, and finally the conclusions. First, in introduction, I am going to talk about the growing demand of for wireless communication service requires device with great performance, and antenna plays essential role in transmission information over long distance. And the second, the new communication technologies include 5 gigahertz recursive wideband and multiband resonance antenna that can cover different resonance frequencies. And three, to meet requirements and short-range communication system, ultra-wideband antennas are used due to their high transmission rate, low and power requirements, and low sensitivity to multiple loss. The patch antennas or microstrip, it's a good alternative because you can reduce the cost, reduce the dimensions and geometry shapes, and allow the miniaturization. Different techniques have been developed to obtain a wideband range, such as the insertion of slots of different shapes located in the patch feeder or ground of the plane. In this case, we propose the insertion of various slots and geometric figures in antenna with ultra wideband characteristics to operate in the super wideband range. The antenna design, here is the initial antenna design. In this case, it is a rectangle monopole antenna. It is powered by microstrip line. Patch is shaped like a rectangular with a conical section at lower end. This network is used to improve antenna coupling, and it is also expanded. It is band wide. Additionally, 2 slots have been inserted into upper ends, and the particular ground another side subtract outlet. This variation in antenna geometry contributes to increasing resonance frequencies and decreasing reflection coefficient. Sorry. Here is the process of the antenna design. It is a process that is summary. In the next period, where an empirical process is presented. To initiate the process, you need to resonance frequency gain and size. First, you can patch, you can modify the patch, and you can have a ultra wideband. If your answer is yes, go to the next step. US slot insertion. US slot insertions improve on antenna. If the answer is yes, you can go to the next step. Can insert a circle slot. It is the final step. You can, if the all answer is yes, you can build the antenna using a laser to the best precision required for final design. Here is the illustration that the process design, and it is the initial design. In the stage, it is the first iteration, and where I insert two rectangular slots. Later, you can see the you shape it, inserted, and finally inserted four circles that I simulate the eyes, and the U-shape simulate the mode that is the name is my antenna. Here is the result that simulate. In the purple, we can see the result of the final design that you can see that super 20 gigahertz. In the final design, in the table, you can see more detailed the dimension of the antenna. Here you can see the measure and resulted, and in the right you can see the manufacture of for characterization, and there is the simulate. In this case, we use a laser to imprint that. Here there are the final results that simulate and measured. They are different, and you can see in the measure is only to 50 gigahertz, because in the laboratory of here, BNA is only characterization. Here you can see the azimuth and elevation plan and 3D radiation. In this case, only simulate to do 2 gigahertz, 3 gigahertz, and 4 gigahertz. In conclusion, the main result of our work is to demonstrate that with simple modification, it's possible to expand antenna bandwidth. We managed to transfer our ultra-wideband antenna into super wideband with a slot insertion of different geometries. Although the objectives set are met, there are different between measures and simulated results. These variations are due to different conditions that occur at time of antenna building, such as material of type in manufacturing process. Measure and simulate radiation partners exceed variation manually related to gain. This is to do conditions which antenna was characterization without having an anaerobic chamber. Thank you.
In the penultimate slide, if I may, you were citing some limits, if I understood correctly. Can you elaborate further? Yeah, on it is not possible within a context to expand the range of tests because we do not have transceivers that work in larger ranges. Can you explain further, please, this point?
It is not possible within our context to expand range of the test.
Yeah, these limits.
Okay. Here we don't work with another frequencies because I say that the VNA of the university don't have more distance, and there is more noise in here. Thus, it is impossible to have more results of that.
Okay, thank you. Fair enough.
Okay.
Okay, thank you so much for the wonderful presentation. And now we are moving forward to our last presenter for the session. And I would like to invite Dijana Oreski to present her paper on the title Towards Learning Analytics in a Distributed Learning Environment. So, dear presenter, you can please present your paper now.
Thank you very much. Okay, I believe that now you can see my screen. Hello, greetings from Croatia. My name is Jana Oreški and I'm Associate Professor at the University of Zagreb, Faculty of Organization and Informatics. And here I will present the paper entitled Towards Learning Analytics in a Distributed Learning Environment. The paper is written with my co-authors, full Professor Vjeran Strahonja and Assistant Professor Darko Andročec. Here is the brief content of the presentation. Basically, I will try to give you answers on 3 questions. First one is why we consider this topic valuable to investigate. Second one is how did we design and perform research. And the last one is what we got as the results. And here I will talk about Moodle analytics and YouTube analytics. First, just let me give you brief context of the research. This paper is written under the European Commission supported Erasmus Plus project entitled Better Employability for Everyone with APEX, or acronym B APEX. And the aim of this project is to increase employability of students which are from non-technical majors by developing courses, learning and teaching materials which propagate the use of low-code software. And we are using Oracle APEX. In this paper, we are investigating how students used Oracle APEX, how they used different materials which were developed for the students to learn how to use Oracle APEX. So today, universities are using virtual learning environments and more of them, and they combine them in distributed learning environment. And of course, distributed learning environment consists of different systems. Here are enlisted some of them. So that can be learning management system, right, like Moodle. That can be platform for application prototype development, like Oracle APEX, some modeling tools, or other learning resources like Oracle Academy or YouTube. Such systems generates huge amounts of data, and that data is potentially useful. However, it needs to be extracted from various systems, integrated from different sources, and then analyzed. And that process is rather complex. So in this paper, we are striving to do the first step toward developing a learning analytics framework in a distributed learning environment. And by providing such a framework, we want to get a deeper insight into students' activities so that teachers can make better decisions about how to support students' learning and learning design. Our case is based on course information systems development, which is taught by the authors of this paper at the University of Zagreb at our faculty. At that course, we have used 3 systems. First one is Moodle, like learning management system. Then we used Oracle APEX to develop a prototype of applications. And we have used YouTube, where we posted videos which explain students how to use Oracle APEX, and links to that videos were posted to students at Learning Management System, and they assessed that materials. The research question that we investigated here is formulated like this. How can we empower student activity and achievement by data collected in learning management systems, combined with data collected in other parts of distributed learning environment? And the main aim is to improve learning analytics and learning design. We have used the data which were collected from one generation of students at the course Information Systems Development, and the sample consisted of 187 students. The course was taught as hybrid, so it consisted of lectures, seminars, and laboratory exercises, and that was combined with different activities that students had to do at the Learning Management System Moodle. We have extracted a lot of data about students' activities at the learning management system, but here we have focused on the activities which were related to usage of Oracle Apex. So that are the videos that were provided to students as links at the model, but also an assignments that they had to do, which were related to those videos. And here you can see the list of the variables that we have used in our paper. Regarding the topics of that videos, those are the topics: how to use Oracle Apex, how to create tables in Oracle Apex, how to edit simple forms, master detail forms, how to create reports and views. So what we got as the results, first we take a look of how much of the students did use that resources of activities. And here you can see numbers regarding the unique users and number of overall logs to certain resource or activity. Those results are visualized here, where you can see which is the overall number of logs per activity and resource regarding the usage of Oracle Apex. As you can see here, 3 bars are standing out, and those are the ones that are related to the submission of assignment that students had to submit. When taking a look at the unique users, you can see that here distribution is almost uniform, which means that for each of the resource or activity, most of the students at the course did assess a certain activity or resource. Then we wanted to take a look at temporal component to see when do students log on to certain resource or activity by the day in a week. And here you can see that Sunday is a day in a week when most of the logs were performed. The reason for that is that their deadlines for assignments was always end of the week. That means Sunday, and most of the students submitted their solutions last minute, last day, which is Sunday. The second highest bar here is Monday, and most of the exercises, most of the lab groups was held in the Monday, so that's probably the reason why number of logs is higher than in other days in a week. For the other days, we can see that that the distribution is similar for that days. So that was the part regarding the Moodle analytics. We also wanted to see analytics of YouTube videos that were posted students at the Moodle. And for 4 videos that students had as materials, on this table you can see their duration and average percentage of views. What we can see here is that the longest video has the lowest average percent of views, whereas the shortest video has the highest average percentage of views. So students were more focused on the videos that were shorter. Next, we wanted to see the content of that videos and the complexity of the topics that were that was covered by the videos. And here in the second column, you can see complexity measured as subjective category assessed by teachers. So we had 3 categories here, video of small complexity, medium, or a high. And we wanted to compare that with the number of dips and spikes, which can be extracted from YouTube analytics. What are spikes and dips? Spikes are the moments at the video when viewers are rewatching a certain content, and the dips are when someone is leaving the video on a specific part. So we assume that if there is a higher number of dips and spikes, that it could indicate that the content covered by the video is more complex, and the other complexity measure is gained as sum of number of dips and spikes. And what we can see here, that the video which was the most complex by perception of teachers as high. So fourth video is also of the highest complexity gained by number of dips and spikes. So this could be considered as a measure of complexity for the videos. So to conclude and to give some guidelines for future work, so here we wanted to identify patterns in student behavior by combining data from learning management system and YouTube analytics. In the future work, we want to integrate it with the data from Oracle Apex to get more integrated approach. Of course, there are some potential GDPR issues, and we will deal with that. Also, such integrated data could serve as a good basis for development of predictive models of students' success, which could help in a dropout and for the students. And at the end, there is possible future research in concerning the time complexity of the proposed framework. Thank you very much for your attention. If you have any questions, I will be happy to answer.
I'm wondering, in relation to the GDPR issue, how are you going to tackle the requirements of the GDPR? Because looks like a critical issue.
Yeah, we didn't come to that point, but we are aware that it's a critical issue.
Okay.
Okay, so thank you so much for the presentation.
Thank you.
And with that, we have completed all the presentations for today. And I sincerely thank all our authors for their excellent presentation and contribution in this session, and all the participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, thank you for your support during this 8th version and the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2024. So all the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months, so kindly cooperate with the team of ICICT. And I would also like to thank our session chair for chairing the session. And here is a small token of appreciation on behalf of the team of ICICT, Global Knowledge Research Foundation, and the partners. So thank you so much for your valuable presence, sir.
Thank you.
And now, as we have come to an end of the session,
Many thanks.
I request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay, thank you so much, everyone. Stay safe and take care.
Thank you. Thank you.
Thank you. Bye-bye.
Thank you.
Bye.